Hi everybody. In this lesson we want to look at the difference between odd and even roots, in particular some higher roots than just the square roots and cube roots that we may have seen before. Alright, so the fifth root of 32, again the index here is 5 and the radicand is 32, so I'm looking for the number that I'd multiply by itself 5 times to get 32. Well, just a little psychology involved with these math problems. If the number is going to be very nice, there's only a limited number that you can multiply by, and you could multiply a number by itself 5 times and have it be very small. So in this case, it is just 2. 2 times 2 times 2 times 2 times 2 does give you 32. And then the fifth root of 32 with a minus sign in front, well, that's just what I did over here. I just stick a minus sign in front of it, so that would be minus 2. Again, because 2 to the fifth is 32. And then if I stick a minus sign on it, I get that. The fifth root of a negative 32, I'm looking for the number I'd multiply by itself 5 times to get a negative 32. And I can do that. And that's actually negative 2, since if I take negative 2 and multiply it by itself 5 times, that does give me negative 32. All right, negative 2 times negative 2 times negative 2. Well, there's negative 8, right? Another negative 2 makes positive 16, and another negative 2 does make negative 32. All right, now I want to compare this similar problem with an even index down below these. The fourth root is 16. That's 2, because 2 times 2 times 2 times 2 is 16. And if I had the fourth root of 16 with a minus sign in front of it, that's minus 2. But the difference comes right here. The fourth root of negative 16, I'd have to have a number I'd multiply by itself 4 times to get a negative number, and that can't happen, right? Because if you ever multiply a positive number 4 times, you'll get positive, and you multiply a negative number 4 times, you'll get positive. So you can never get a negative number multiplying at least a real number by itself 4 times. So this answer is not a real number. So the odd indexes don't give us any problem with domain, but here an even index, you can't take an even index of a negative number because it will there's no real number you can multiply by itself an even number of times to get a negative number. All right. If we have some expressions dealing with even indices, you have to be careful to use the absolute value. So if I had the 8th root of x to the 24th, I'm thinking, what could I multiply by itself 8 times to get x to the 24th? Well, that would be x cubed, right? X cubed times x cubed times x cubed. If I do that 8 times, I'd end up with x cubed to the 8th power, and I'd multiply those exponents, and sure enough, that'd give me x to the 24th. But notice just a minute here, if I were to take a negative 1 to the 24th power, that would be a positive 1, wouldn't it? And then the 8th root of a positive 1 would be 1. But that's not going to be negative 1 cubed, right? Because negative 1 cubed would be a negative 1. So I have to be very careful if I take an even index, an even root, to put absolute values around that. Now this next example, the 8th root of x to the 16th would be x squared. And technically you need absolute values around that as well. But in this case, because the x squared is always greater than or equal to 0, in other words, you can't have that be a negative number, then I really don't need the absolute values, because the absolute value of a positive number is just the number itself. So I could drop the absolute values there and just leave my answer like that. It's a little simpler. Okay? Likewise here, the fourth root of 2x plus 7 to the fourth root is going to undo the 4th power, and you're going to get 2x plus 7. But I also need to remember those absolute values, right? If x happened to be, well, let's say x was negative 4, well, then you'd have 2 times negative 4 is negative 8 here, plus 7 is negative 1, and of course negative 1 to the 4th power is a positive 1, and then the 4th root of that would be 1. But if I came over here and put in negative 4, I'd get negative 8 plus 7 is negative 1, and it wouldn't be right unless I lop off that negative, all right, which I do with the absolute values. Okay, one last problem right here, the fifth root of negative 32x to the 10th. Well, the fifth root of negative 32, we saw that's going to be negative 2, and the fifth root of x to the 10th, that would be x squared. If I multiply x squared by itself 5 times, we'll get x to the 10th, just like if I multiply negative 2 by itself 5 times, I'll get negative 32. Because it's an odd root, I don't have to worry about absolute values. The only time I have to worry about that is if there's an even root. Okay?